Hello and welcome to Mr. Thompson's Math Tutorials. Today what we're going to do is look at simplifying fractional radicals. So that's essentially a radical, so a square root or a cube root or something to the fourth root that has a fraction inside it. So first things first, we are allowed to do this, and this is an important part of solving these kinds of problems. You're allowed to write it in this form. So I can take them sort of apart and make them into two separate problems. And that's really what I want to do to solve these kinds of problems. So what I've done here is I've separated the square root of 12 and the square root of 21 and just put them over each other in a fraction. And this is completely and totally okay. In fact, the two of them are 100% equal. And then essentially what I'm doing is simplifying this and simplifying that. Okay, so let's look at how that works. When I simplify the square root of 12, well, what I want to do is look for those perfect squares. So that would be 4 times 3. Okay, those are the factors that are going to give me perfect squares. And I want to see if there's any perfect squares in 121. So, well, actually there is, because 121 is a perfect square. It's 11 times 11. So the square root of 121 is actually just simply equal to 11. So that one's solved. The square root of 4 is 2, so I can essentially pull that out of here. So it can just come out as a 2. Okay, so that means that this is 2, and what's left in is the square root of 3. And this is all over 11. And this is completely simplified. Let's look at another example. Here we go. This one is a little different in the sense that it has this 5 on the outside, which I need to pay attention to. So I'm going to start by separating these. So this is 5, and I have to realize that there's a multiplication sign between this 5 right here and the radical sign. So I'm going to put my square root of 32 up top and my square root of 12 on the bottom. Okay, and now I'm ready to simplify this. Now my 5 is essentially going to be carried through for quite a while. Okay, so let's see. The square root of 32 is, well, the perfect squares that I see in there. I see, if I look at the factors of 32, I've got 1 and 32. I've got 2 and 16. I've got 3, no, 4, yes, 4 and 8. 5, no, 6, no, 7, no. So, okay. So we're good right there. We've got all of our factors, and I want to look for the biggest perfect square in my list of factors, and it happens to be 16 right here. So I'm going to pull that one out, 16 times 2, and factors of 12, I end up with 4 times 3. Okay, so I can find the square root of 16, that's a 4, so that's going to go up top there. And I can find the square root of 4, that's a 2, it's going to go up top there. So this would be 5 times 4 times the square root of 2 over 2 times the square root of 3. Now, I can further simplify this. This is 5 times, I'm going to pull this out because basically this is completely and totally allowed. I am allowed to pull out this 4 over 2 and make this into three separate three separate parts of a multiplication problem. And then I'm going to simplify this 4 over 2 because that's essentially equal to 2. So this is equal to 2 times the square root of 2 over the square root of 3, which is equal to 10 times the square root of 2 over the square root of 3. And this is completely simplified at that point. Let's look at one more example. Okay, this one has a cube root in it, so I've got 4 times the cube root of 48 over 162. Okay, so let's solve this. To start, remember what I can do is put a multiplication sign between my 4 and this cube root. And just like with square roots, I can separate this into essentially two simplification problems. So this is the cube root of 48 and the cube root of 162. Now I'm looking for perfect cubes. So I'm looking for 8, which is 2 times 2 times 2. I'm looking for 27, which is 3 times 3 times 3. I'm looking for 64, which is 4 times 4 times 4. Those are going to be kind of the biggies that I'm looking for. So as I look at 48, I'm going to think of the factors of 48. And the factors of 48 that have a perfect cube in them. So that would be 8 times 6. So I'm going to have 8 times 6. Okay, good. Now, 162. Well, teachers usually want you to find these perfect cubes. So what I might try to do is see if any of these actually are factors of 162. So I'm just going to quickly divide 162 by 8. So here's 8. So how many 8s are in 16? Well, there are 2. 2 times 8 is 16. I subtract, I get a 0. I bring down my 2. How many 2s are, okay, so I'm going to get a fraction here. So it definitely wouldn't be 8. Okay, so not that one. Are there 27s? Is there a 27 in 162? Well, let's see. So 27 times 4. Let's see, 27 times 4. Oops, that's a 24 times 4. Let me just fix that for you. 27 times 4. Well, 4 times 7 is 28, carry my 2. 4 times 2 plus 2 is 108. So not quite there. Well, what about 5? Well, it wouldn't be 5 because if I multiplied times 5, I would end up with a 5 in this digit or a 0 in the ones place. So it can't be 5. How about 6? Let's just check 6. So 27 times 6. 6 times 7 is 42, so there's my 2. I'm going to carry my 4. 6 times 2 is 12, plus 4 would be 16. Ah, there we go. So I can see that the cube root of 162 is really 27, which is a perfect cube. That's one of the ones I'm looking for, times 6. Okay, now I'm going to solve this. We can see that the cube root of 8 is actually 2 because 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, so the cube root of 27 is 3. So that would mean that this is 2 times the square root of 6 over 3 times the square root of 6. Okay, good. Now I'm going to pull out and separate this into 3 different parts. Now, whenever you see the same thing over the same thing, that should be a signal that you've got something special. And this is that power of 1. This is actually a fancy way of writing the number 1. Okay, because 6 over the square root of 6 over the square, oh, and this is, sorry, the cube root. I apologize. I've forgotten my cubes. I'm asking, this is a division question now. I'm asking how many cube roots of 6 are in 1 cube root of 6? And the answer is 1. And that is why that's equal to 1. So this is simply equal to -4 times 2/3. Okay, which is equal to -4 over 1 times 2/3, which is -8 over 3. And I can just leave it in that form. All right, perfect. Thank you for watching.